to the more complex problem of multi-agents with Pommerman. In a second.
Cool. Hi, my name is Cinjon Resnick. I'm going to talk to you today about Pommerman. And before I dive in, I do just want to mention that this was a team effort. My co-conspirators include Wes, David, Denny, Jacob, Julian, my advisors, Cinjon, and Juan. I'm also very indebted to the Discord community that's built up around this. And if you haven't checked it out yet, I have a lot of members, and they're always very helpful towards people who are getting started with the environment, which I'll explain right now. So what did we do? We made a multi-agent research environment. And I'm very pleased to say this is going to be quite complementary to Martin's wonderful talk. This is the classic game Pommerman. It was made by Nintendo back in 1983. It's been a fan favorite ever since. What you see here is 4 agents, each starting in a different corner and playing against each other. Their goal is to be the last agent standing. And they do this through laying bombs and picking up items. I'm gonna play this for a little bit just so we're all on the same page. So you can see in the top right, that agent's gonna accidentally kill itself fairly early on. In the top left and the bottom left, they're going to get into a nice skirmish, while the one in the bottom right cleans up all the items that the one in the top right left behind. You see the skating one makes you go fast. The flame one has farther extension on your bombs. I think he's about to trap him. The white one's about to trap the red one. Yeah, got him. So now it's time to go and take down the white versus black here, and he actually does get him. So even though he had an advantage, the white one got him. So this game is a lot of fun. I played it a tremendous amount growing up. And originally it was played as a free-for-all, but later versions did incorporate team. However, it's always fully observed. This is our game, Pommerman. Partially observed Pommerman. Now, I did expect a couple laughs there, but our crowd, it's all right. Our board is slightly different. It's randomly generated each time, but the gist of the game is the same. On the left, you see the God view. On the right, you'll see each agent's viewpoint. Now, they are items uncovered by blowing up walls, et cetera, et cetera. You can find extra bombs, farther range. It's really similar. And just want to point out that code there, had it up since February. It's really developed quite well. And the website is fully functional. You can go and join our competition, which I'll explain a bit later. This is the starting state of a randomly drawn board. In a free-for-all, the agents would see the whole board. It's fully observable. In a team game, it's partially observable. They get to see only the 9x9 grid with them at the center. In a team game with communication, they additionally get to pass cheap talk messages to their teammates, which are discrete messages. On every turn, you pass each agent discrete observations representing the game state, and we receive from them one of 6 actions representing each either move in a cardinal direction, pass, or lay a bomb. And last, in a communicative environment, they also send back a cheap talk message that will be sent to their teammate. Now, I just want to point out that those things I mentioned, all of it is discrete. There is no thing here of you're trying to learn from pixels, none of that. We wanted to make an environment that was dedicated towards multi-agent research. So we stripped away all of the components that would otherwise make it difficult to focus on the strategy of multi-agent components. Why? Well, we were seeking a cohesive benchmark. Might be somewhat controversial given the last talk, but I'll explain why it falls in line. So in 2016, AlphaGo beat the world's best to go. This community is well aware of this, but it's wanted to remind everyone that it wasn't really expected to be surmounted for many years. Its successor, AlphaGo Zero, did the same thing for chess and was even better. You could argue that all zero-sum perfect information games, modulo computation time, are solved. In early 2017, DeepStack and Lebradas did the same thing for poker. one of the most complex imperfect information games that humans play. Further, as we just went through, very, very well done, their solution converges to a Nash equilibrium. So again, modulo computation, we're really not going to do any better. That's not to say we're completely done with this game, though, or this genre, I should say. OpenAI's recent endeavor with Defense of the Ancients, which reduces to 1 versus 1 zero-sum game, regardless of how many teammates are on the team, because they don't use any form of communication or whatnot, highlights that we still have a lot to understand. With Pommerman, we wanted to push for another track. We wanted to see the community move on to other challenges. In particular, we wanted to create a benchmark for other challenges. Here are 4 of them for which we don't see any reasonable approaches. And notably, there are many efforts to tackle these. But when we looked around, we noticed there wasn't any cohesive effort, any benchmark, anything that the community was rallying around. Instead of having something like poker, Go, or chess, which pushed forward the state of the art for many years, people were using one-off toy tasks. Pommerman is an attempt to address this, and it was chosen because we thought it really matched a set of research criteria that would make it a nice target for years to come. The research criteria includes being easy to integrate into common research setups. It uses Gym under the hood, which is a very popular Python setup that OpenAI exposes. It has intuitive mechanics and gameplay. As I mentioned, I grew up playing this game. It's something that many kids learn as one of their first games that they pick up. It's a learning problem that is not perceived as insurmountable. State-of-the-art algorithms today do a reasonably okay job. And it's fun. It's a fun game to play and watch, which, when you look through the history of benchmarks, has actually been a pretty important component. Now, one existing environment that arguably could have worked is RoboCup Soccer. This competition has been running since 1997. However, I wanted to highlight some key differences that I think kind of kept it back. One, it has sensory input. We stripped away this sensory input. This sensory input is very good for robotics applications, but it's not so good when what you want to do is multi-agent research and strategic research. Second, we have only 2 sides, 2 per side rather than 11 in the team game. The free-for-all, obviously, there's no such concept really a side. But this makes it more amenable to current and near-future research directions. 11 is pretty hard to handle with what we understand. And 3, humans can actually play our game. You can't really play RoboCup Soccer. It's quite hard to get 11 on 11 humans to play the game, or even a few to do it at any given time. And this HCI component is actually something that we haven't really driven too hard yet. It's only been the first year of existence, but one which we think has a lot of promise and fruit to bear. Now, there is a variant of RoboCup called half-field offense. This similarly reduces much of the complexity of the game to just a 3 versus 3, and it focuses on decision-making and strategy. It too suffers from being reducible to 1 versus 1 game, and also keeps sensory input. And this may have been picked up. There is an alternate future where it does get picked up. It's only been around for, I think, end of 2015. But for whatever reason, it hasn't been, and we think one of these reasons are plausible. Now, this talk serves not only as a notice about Pommerman as availability as a research environment, but also as a check on the progress so far. We debuted the environment in mid-February of this year, just as a reminder. In short, it's challenging. Without a very large batch size and shape reward, neither of PPO nor DQN really learn anything out of the box. This is against the default expert that we shipped it with. Now, one reason for this is because the game has a unique feature. The bomb action is highly correlated with losing in the short term. It is, in the beginning of the game, when you're just on an island cornered by yourself, it frequently will kill you. And so you learn not to use it. But in order to effectively win in the game, you need to be able to wield this bomb. And there aren't many environments that have this attribute. However, increasing the batch size, shaping the reward, or a technique I'm going to describe a bit later that we recently published, all help with this. So we don't actually think this is a roadblock tool where it's using it as an environment for multi-agent research. Imitation learning could also be used to get around this. And the handcrafted expert policy that I described earlier, you can train a Dagger agent against this, and it achieves a similar success rate of 20% for winning. So again, we don't think this is a real problem. just to sort of share with you some research findings as far as the environment goes. So competitions. We ran a free-for-all competition in June of this year. There were no prizes, and we had 8 entrants. The winner was a finite state machine tree search approach, and I'm going to show you how that looks. Yeah, so what you're going to see is in the top left, this agent is not going to do anything. That was his attribute. In the bottom left is his blue one. He was a second place agent. He was very good at beating this agent, this purple one, which is the expert that I shipped with the game. And the top right is the winner of the actual competition. He was the tree search one. So in the beginning, they ended up having a lot of, a nice few skirmishes. And I don't think they meant to do this. Actually, I know they didn't mean to do this because I've seen their code. But those guys team up on the green one. And he was the winner of the competition, but this is one where he lost. And at this point, he got him, so expected. He's very good at beating those. And now he's like, where is this guy? Where's he doing? And he's got this game in hand, right? Like he's thinking, I gotta find this dude. I've killed my 2 tough teammates, 2 tough competitors. And so he finally finds him and he traps him. And that's the way this game ends. It goes on for the full 800 steps, but this lazy agent, happily named crappy agent, he ends up tying this game, and it's really sad because he had it in hand. We have all the battles, by the way, from that competition on a similar format website. Okay. In less than a month, we're going to be running a competition at NIPS. This will be run live. It'll be streamed over the internet. It's going to be a 2 versus 2 partially observed competition without communication this time. And so I'm pretty excited because the entrance just opened this past Sunday and will go on, as in you can submit agents starting this past Sunday, and it will go on until the 21st of November. I do not know how many entries we're going to get, but given the number of users we have signed up for the website and the number of people in the Discord community, I'm fairly optimistic about this. People have known about it since end of March. They've had quite ample time to develop agents, and I think it's been pretty good. Definitely, if you're at NIPS, come check it out. It'll be on Saturday, and if you're not, we'll stream it live on Twitter, and on Twitch, and I will send a link to that. So I'm aware of 3 published papers using this environment, one of which is the one I mentioned earlier. We sent this to AIIDE. It's currently going through reviews right now. It's called Backplay. I'm not going to talk too much about this. I'm just going to, it's not the focus of this talk, but I'm just going to briefly describe this diagram as it succinctly conveys the idea. So we explored on this only the free-for-all environment. On the left, and it's a way of getting a much better sample complexity in RL by being able to change the state distribution. So on the left, we play Pommerman as normal, but we record all of the states. And then for our purposes, for doing this, we use 4 copies of the agent that won that last competition. That yields a single demonstration game after watching the expert play, with the expert being the winner of that game. We then break that demonstration into a curriculum that's defined by a sequence of windows and the epochs associated with those windows, where we advance them forward. I honestly don't want to go into this too much, but there's a full paper you can look at there, and if you're at all interested, it works really well for reducing the sample complexity of these games. What is cool, though, is the agent that was learned from that policy. So you can see the red agent here is the one that we learned, and it learns a completely different way of playing the game than any human I've ever seen play, or any of the agents that were entered into competition. Mainly, it plays projectiles. So you can see this is the beginning. It's going to pick up a can kick at some point. It might have already done that yet. And now it starts throwing bombs. So it plants the bomb and then it kicks it at the other players. And this was really cool because actually, I mean, again, I've never. All of a sudden, this started emerging. You're like, why does he not care about traversing the board or no? Because he found his can kick.
Can I just ask, is this an earlier version of Pommerman, or did you build a simulator?
This was before, so people in the community convention have built a lot of things.
Okay.
And one of the things they did is they built better graphics.
So it's the same underlying
it's the same
engine.
Everything.
Okay.
It's just it's
Okay.
Cool. Yeah. The other thing, by the way, another aspect of strategy that isn't highlighted by this GIF, but the agent also learned to wait. So a lot of times it'll be just waiting in a corner and chilling while other agents go and beat up on each other, and that's pretty high level free for all strategy, which is cool. Okay, so our takeaway for this talk, so we really want you to go home and try this environment. We think it's very rich, lots of room to explore, whether it's end player pursuits, there's communication research, whether it's partially observed communication settings, all these things. I think that there's a lot to see here and to try here, and this is the right community for exploring these things. This is not in, I mentioned earlier, this is very much in line with what Martin was talking about. And he's saying, hey, look, there's this fertile field of still things to do in 1 versus 1. And what I'm expressing is, hey, look, over here, there's this entire green space of things that really haven't been explored. It's ripe for doing that right now. And the theory is going to be very hard, but empirically we can demonstrate a lot. And that's what I'm pushing for as a research agent. But ideally, you'll join our competitions as well. Thanks. And if you want to do that, by the way, all the code is here, the website's there. If you need help setting up, feel free to email me at any time. But otherwise, happy palming.
What's the format of final?
It's 2 versus 2, partially observable, no communication.
For how many rounds? What's the
It's going to be best of 3 per battle. So each entrant, obviously, Team A, Team B, they'll each submit 2 agents, and then they'll be best of 3, and double elimination on that.
Do you have model or model free?
I'm sorry?
Do you have model or is model free?
So the agents can feel free to train themselves any way they want. We do provide a forward model in the code base.
Including during the competition, or?
You have your own Docker environment, and you can do whatever you want in that Docker environment outside of, I mean, there's a certain amount of things within the spirit of the game that we don't allow, but otherwise you can do whatever you want.
Did you submit agent?
I did not, no. So the free-for-all one, I did submit the simple agent because I made that and it's like, all right, let's do that. For this one, I did not. I didn't think it would be fair for changing the game that way. But B, I also just haven't had time.
Can you compare search-based and the learning-based approach in MARLO?
I would love to see that come from this. What I did to try and inspire that is a part of the $20,000 in prizes that we've found for this is actually a large chunk of that is going towards prizes for the best learning agent. So we're trying to get people to make not just fixed agents, not just rules-based ones, but also learning-based ones, search-based ones, whatever. We want to get those things coming to try to incentivize that.
There are 2 tracks.
There aren't for this. So originally we did think about doing 3 tracks, actually. And in an effort to focus the first year of this, we really wanted to pick one. Yeah. So there was one in June that was free-for-all. There's one now that's competition. There's actually the community, in fact, which is awesome. They're going to have another free-for-all competition on November 24th, which just sort of happened fairly organically.
Just out of curiosity, how do you hand code agents actually do on this? Just hand code policy.
Yeah. So the winner of the free-for-all was not, right? He was the search-based one. Yeah, search-based one. The second place one, which I showed, that kind of got stunted by the bad agent in the end. He took the agent that I made, that simple agent, and he made a bunch of changes. So that was a hand-coded policy. I suspect that they would do pretty well. So that's why I'm trying to. I do expect they would do pretty well until all of a sudden they're going to be trounced at some point by learning agents, and that's why I'm trying to incentivize learning agents through the money.
Was only the top one the one who learned to keep bombs like that?
So that was the one that I made. That was the one that came of the research I was doing.
Okay.
And yes, that was the only one that did it. It was not entered into the actual competition.
Okay.
Honestly, though, I've never seen that strategy before. Like, I played this game a lot growing up, and I've never seen anyone do that strategy.
It seems like it would exploit agents who didn't realize things were moving in the game like that.
That's right. That's right. Yeah. So I don't know how well. It probably wouldn't do too well against humans. Although it might just like the surprise of seeing that kind of thing the first few times.
Thank you.
Thanks.